Look outside your window right now. Whatever you see, sunlight hitting a sidewalk, a tree casting a shadow, a blue sky, all of that exists because a thin layer of gas about 25 kilometers above your head is filtering the radiation that would otherwise sterilize the surface of the Earth. You never think about it. Nobody does. But 74,000 years ago, that layer nearly vanished, and your ancestors were standing under the open sky. When it happened, the island of Sumatra in Indonesia sits on top of one of the most violent geological systems on the planet. Beneath the surface, the Indo-Australian tectonic plate grinds under the Eurasian plate at a rate of 56 millimeters per year. Pressure builds, magma collects, and 74,000 years ago, that pressure released in the largest volcanic eruption of the past 28 million years. The Toba supervolcano didn't just erupt, it detonated. The explosion ejected 2,800 cubic kilometers of rock and ash into the atmosphere. To put that in perspective, the 1980 eruption of Mount St. Helens, the one that flattened 600 square kilometers of forest, released about 1 cubic kilometer. Toba released nearly 3,000 times more. The caldera left behind is still visible from space. It filled with water and became Lake Toba, stretching 100 kilometers long and 30 kilometers wide across the northern Sumatran highlands. Pyroclastic flows, walls of superheated gas and rock moving faster than any vehicle on Earth, buried 20,000 square kilometers around the eruption site. Ash rained across Southeast Asia, across the Indian Ocean, across the entire Indian subcontinent. In parts of central India, that ash settled in layers up to 6 meters deep. Across broader South Asia, a blanket of volcanic debris, 15 centimeters thick, covered the landscape. Plants suffocated, rivers clogged, the sky turned gray. But the ash was only the beginning. Billions of tons of sulfur dioxide launched into the stratosphere, and that gas did something far worse than block sunlight. It triggered a volcanic winter. Global temperatures dropped 3 to 5 degrees Celsius. In higher latitudes, regional cooling reached 15 degrees. The volcanic winter lasted 6 to 10 years. After that, a prolonged cooling period stretched across the next 1,000 years. To understand what that actually means, consider Mount Tambora. In 1815, Tambora erupted in Indonesia and killed 71,000 people. The following year, 1816, became known as the year without a summer. Crops failed across Europe and North America. Famine spread, livestock died, and Tambora was roughly 100 times smaller than Toba. Whatever devastation Tambora caused, multiply it by a factor that scientists still argue about, and you begin to approach what Toba did to the planet. Imagine Africa 74,000 years ago. Summer does not arrive. The rains that usually sweep across the savannas in predictable cycles stop coming or come weaker. At the wrong time, flowers do not bloom. The grasslands that feed the antelope herds turn brown and thin. The antelope themselves grow weak and starve, their bones visible beneath thinning hides. The predators that depend on them, including your ancestors, suddenly face a world where the food chain is collapsing from the bottom up. Trees die, rivers shrink to muddy threads, waterholes that sustained camps for generations dry to cracked earth. The sky stays a muted gray for month after month after month, and nobody alive understands why. That is the popular version of the story, and for decades it shaped how scientists understood what happened next. In 1998, anthropologist Stanley Ambrose at the University of Illinois proposed what became known as the Toba catastrophe theory. He argued that the eruption caused a genetic bottleneck in the human population, reducing the entire species to fewer than 10,000 individuals, possibly fewer than 3,000 breeding pairs. The evidence came from modern human DNA, which shows remarkably low genetic diversity compared to other primates. Something, at some point, shrank the human population to almost nothing. Ambrose argued Toba was the cause. For years, this was the dominant story, the supervolcano that nearly killed everyone, the extinction we barely escaped. This decision to accept the bottleneck as fact seemed small at the time. It wasn't. Then, archaeologists started digging. At Pinnacle Point, a rock shelter on the southern coast of South Africa, A team led by Curtis Morian of Arizona State University had been excavating for nearly 20 years. The site sits on a stretch of coastline where ancient humans lived between 90,000 and 50,000 years ago, one of the longest continuous records of human occupation anywhere on Earth. In 2018, they published a study in Nature that changed the Toba narrative. Panagiotis Karkanas, a geoarchaeologist working on sediment samples, spotted a single microscopic glass shard embedded in a slice of archaeological sediment encased in resin. It had a distinctive hook shape formed when volcanic glass fractures across a bubble. One shard out of millions of mineral particles. Chemical analysis confirmed it came from Toba, carried 9,000 kilometers through the atmosphere. From Indonesia to the tip of Africa, that shard was a timestamp, accurate to within a single month across the entire globe, and the layers directly above and below it told a clear story. There was no gap in human occupation at Pinnacle Point. No abandonment, no die-off. The evidence of human activity didn't decrease after the eruption. It intensified. More stone tools, more food processing, more signs of sustained, organized life. The people at Pinnacle Point ate shellfish. They harvested mussels and limpets from the rocky coastline. And coastal marine resources, unlike inland plants and grazing animals, are far less vulnerable to volcanic winter. The ocean acts as a thermal buffer. Shellfish kept growing. The people kept eating. 9,000 kilometers away at Jualaparam in the Jereru Valley of southern India, archaeologist Michael Petraglia found something equally striking. His team recovered over 15,000 stone tools from layers both above and below the thick Toba ash deposit. The tool-making technologies on both sides of the ash were consistent. Same Levallois flaking techniques, same scraper industries, same core reduction strategies, no interruption, no technological collapse. Whoever lived there before the eruption was still living there after it, making the same tools, occupying the same river valley, adapting to a landscape now blanketed in volcanic debris. The Toba catastrophe theory began to fracture, not because the eruption wasn't devastating, it was, but because humans turned out to be more resilient, more behaviorally flexible, and more widespread than anyone had assumed. In Ethiopia, populations shifted their behavior entirely. They abandoned inland hunting grounds, where large game had collapsed, and moved towards seasonal rivers and shallow waterholes. They started fishing, a food source most of these groups had never relied on before. They adopted new weapons, including early forms of the bow and arrow, allowing them to hunt smaller, faster game that still survived in the scrublands. These weren't random changes. They were calculated responses to a world that had fundamentally altered its rules overnight. In South Africa, groups diversified their diets, turning to marine resources, small game, tubers, and roots. They refined their stone tools, improving cutting efficiency with less raw material. At multiple sites, archaeologists found evidence of new tool technologies appearing in the layers, directly above the Toba ash. Not a collapse, an acceleration. The eruption didn't freeze human culture. In some places, it pushed it forward. They didn't just endure the catastrophe, they innovated through it. But here's the detail that everyone missed for decades. The volcanic winter may not have been the worst part. In 2021, a team led by Sergei Osipov at the King Abdullah University of Science and Technology, using NASA's GES climate model, discovered something that had been entirely overlooked. The billions of tons of sulfur dioxide that Toba injected into the stratosphere didn't just block sunlight and cool the planet. The volcanic plume absorbed the ultraviolet radiation needed to form ozone from oxygen. Without that UV-driven chemical reaction, the ozone layer collapsed. Global ozone levels dropped by as much as 50%. In the tropics, where your ancestors in Africa lived, the UV index doubled. Under normal conditions, the UV index near the equator sits around 12, already classified as extreme by the World Health Organization. After Toba, it spiked to 28. Going outside without protection would cause sunburn and eye damage in under 15 minutes. Over months and years, accumulated UV exposure would cause skin cancers, genetic damage to DNA, and reproductive failure. Marine plankton near the surface would die. The base of the ocean food chain would weaken. Crop yields and marine productivity would drop. As UV radiation sterilized surface ecosystems, the researchers compared the conditions to the aftermath of a nuclear war. If Toba's volcanic winter was the fist, the ozone collapse was the knife. Cold kills fast, UV kills slow, and the people who survived had no idea. The sky itself had turned against them, so who survived and why? The answer comes down to behavior. Not strength, not luck. Behavior, the humans who made